A large auto manufacturing company is trying to decide whether to purchase Goodyear or Firestone tires for their new models. They think that Firestone tires might have a longer lifetime, so to arrive at a decision, they look at an experiment where they run the tires till they wear out. We're given our summary information then here. So our first sample, which is looking at our Goodyear tires, I'll just label that as a G over here, has a sample size of 55 tires, so I'll let that be group 1 and 1. We have a mean, so X bar 1 of 40,900, and a standard deviation, so that will be S1 of 3,200. We have another sample then of Firestone tires. We have 40 there. Our mean is 42,800, and our standard deviation is 2,700. What we want to know then, at a 1% significance level, is if Firestone tires would have a larger population mean lifetime. So our null hypothesis is that the difference in the two population means is 0, or in other words, the two population means are the same. And then our alternative hypothesis, looking at the labeling here, Goodyear was group 1, Firestone was group 2. We want to know if Firestones have a larger value. If that is the case, mu1 would be less than mu2, and so this difference would be less than 0. Or you could also write this as mu1 less than mu2. We do not need to worry about specifying anything about the distributions being normal here, because our two sample sizes being 55 and 40 are both greater than or equal to our cutoff that we need of 30, and so our conditions are met for using t-based inference. Our test set then will be the difference in the two sample means up top. In the bottom, our standard error is the square root of the s's squared over their sample sizes. So 3,200 squared over 55 and 2,700 squared over 40. This will give us a test stat of negative 3.13. And what we want to do is look in the left tail or less than that value in stat key. Degrees of freedom based off our sample sizes is the smaller of the two n's minus 1. The smaller n is 40, so if we subtract 1, our degrees of freedom will be 39. So let's go to stat key and look for negative 3.13 in a t distribution with degrees of freedom of 39. So we have left tail, and then we put in our negative 3.13. And we're getting a p-value over there of 0.0017. So comparing 0.0017 to our 1% significance level, or alpha 0.01, our p-value is smaller than our significance level. This would lead us to the conclusion that we will reject our null, and then we want to say that we have significant evidence of our alternative. So we do have significant evidence that if we looked at the entire population, that the population mean lifetime of the Firestone tires is larger than for the Goodyear tires.